Bismillahirrahmanirrahim. Welcome back, guys. Okay, this is Shahfahadkhan, and now we are going to continue with the same chapter, separation and purification techniques. And now in this video, we are doing something very important. That's also important um, with the point of view of your exams as well. Okay, of your CAIE. Okay, so now let's. Assalamu alaikum, guys. Welcome back. Now we are on the same methods of purification techniques and methods of purification analysis. Same thing. Now we are going to move on to the second part, and that is to determine the purity. Determine the purity of a sample. How are we going to assess the purity of a sample? How pure the sample is? How are we going to know if the sample is pure or not? How are we going to know if the sample is impure or is it pure? And again, guys, this is a high yield topic because I have seen many questions in the past papers regarding these. Okay, so you will definitely be tested upon this part, and this is a very basic concept and you must know it. So let's get started. Okay, so now let's read through these important points which I've kind of written down. To determine the purity of substances, we can check their melting and boiling points. The very first point that I must ask you guys to remember is this, that the very first factor that affects the purity, or the very first factor that can give us an idea of the purity of a substance, is its melting and boiling point. If the substance is pure, it will melt and boil at fixed temperatures, but if it is impure, then it will melt and boil over a range of temperatures, meaning it will start melting at, let's say, 10 degrees Celsius. And this is just an example. It starts melting at 10 degrees Celsius. And during melting, the temperature should remain at 10 degrees Celsius, right? It shouldn't change for a pure substance. But this temperature would change to 11, 12, and then the melting would complete, right? The melting process would complete and it would have completely molten. So this is a range from 10 to 12, and that's an impure substance, okay? And for a pure substance, if it starts melting at 0 degrees Celsius, for instance, if we talk about distilled water, it starts melting, meaning ice starts melting at 0 degrees Celsius, right? And that's the temperature. It will remain at 0 degrees Celsius throughout the melting process. And then after 0 degrees Celsius, when it has molten completely and it has converted into water, only after that will the temperature start rising back, right? It won't rise above 0 degrees Celsius during the melting process, okay? So remember that. That's a key difference between pure and impure substance. Okay, so now let's read through the second line. Pure substances have fixed melting and boiling points. I've talked about that. Impure substances have a range of temperatures over which they melt, okay? In other words, I could say, um, even if you talk about the freezing point, freezing means the reverse of melting. For a pure substance, for example, water, the freezing point is 0 degrees Celsius, right? So it should remain at 0 degrees Celsius throughout the freezing process, but it doesn't remain for impure substances, okay? Now, what is the effect of impurities? Effect of impurities on the melting point. What do they do? When we add impurities to a sample, these impurities, they lower the melting point for solids and raise the boiling points for liquids. Okay, and this is a key term to remember. This is the fact, okay, a factual point over here. And this has been tested a lot of times in both in physics as well as chemistry. Okay, so what do impurities do to the melting and boiling points? They lower the melting point for what does that mean? Well, if a substance was melting at 40 degrees Celsius, it would now melt at, let's say, less than 40 degrees Celsius, let's say 37 or 35, okay? And if the substance was boiling at 100 degrees Celsius, then now it would boil at, let's say, 110 degrees Celsius, okay, if impurities are present. So that's the effect of impurities on both the melting and the boiling point. And I've given an example over here. If we have pure water, by pure I mean distilled water, okay, having no impurities at all, it would boil at exactly 100 degrees Celsius, and that's true because we know the boiling point of water is 100. But if we talk about seawater, which contains tons of impurities, it won't boil at exactly 100 degrees Celsius, but will boil over a range of temperatures, and most probably will boil above 100 degrees Celsius. It will boil at a temperature greater than 100 degrees Celsius. Why? Because impurities raise the boiling points of liquids, okay? And again, it should have a range of boiling temperatures, and we've talked about the range point as well. even the boiling point won't be constant, but it would rather boil at a range of temperatures. So the takeaway point from here are two. If you have a pure substance, its melting and boiling point will remain fixed, and it will boil or melt at fixed temperature. But if you have an impure substance, its melting and boiling points would change, meaning the melting point would lower and the boiling point will rise, and they'll melt and boil over a range of temperatures. And these are the facts I would want you to learn and never to forget throughout your O levels, throughout your A levels. Okay. Then I've given you an example. Impurity causes benzoic acid. Benzoic acid is a compound. Of course, you don't know what that is, but you will definitely know about that when you come to A levels. But benzoic acid, what impurities do is they cause its melting point to shift in the range, meaning they cause the benzoic acid to melt over a range of 118 to 121 degrees Celsius. It's a range. See, it's not fixed temperature. So that's why impurities, this is the effect of impurities on the melting point. Then, okay, the melting point range of a substance is a temperature range from which the first crystal starts melting and the temperature at which the last crystal finishes melting. What does this mean? Okay, let me explain this. What is melting point range? What is the range of melting point? Well, if you have, let's say, a lump of ice, okay, you've got some ice in your hand or in a beaker, okay, and you put it, and it's impure ice, okay, let me just make that statement clear that it's impure, okay, it's explicitly mentioned that it's impure ice. Now, this impure ice, when you put it on fire or you put it on a flame, what happens? It starts melting, right? Now, the first crystal of ice, as soon as it starts melting, that's the very first temperature, and you record that. And as soon as the melting process continues, and as soon as the last crystal, it finishes its melting, you record that temperature as well, and you'll find out a vast difference in between the two temperatures. The temperature won't stay constant. Okay, this is what the range actually means. Range is actually the temperature from which the first crystal starts melting and the temperature till which the last crystal has completely molten, okay, has completely melted. So that's the range of temperatures. That's what the range actually means. I used to be very confused about this term in my O levels. I still remember, but this is what it actually means. Okay, range means, and this line is not mentioned in your book as well. So please be very careful about it and note it down somewhere. This line over here, that what is range of melting point? Range is actually the temperature from which the first crystal starts melting till the temperature the last crystal has finishes its melting. Okay, so that's the range of temperatures over which a substance melts. And now here's a small question for you. We have 4 substances, and you have to figure out which substance is pure and which substance is impure, and you can choose more than one options. And come on guys, I would want you to pause this video over here and come out with your own answers, and I'll definitely reveal the answer in just a bit. Okay, I'm revealing the answer now. Okay, substance A, if you look at the temperature, melting point, it's fixed, it's at 100 degrees. So is this pure or impure? It's fixed, it's not a range, so it's pure. Substance B, 97 to 99, is that a range? Yes, it's a range from 97 to 99, meaning the first crystal starts melting at 97 and the last crystal finishes melting at 99. So it's an impure substance or impure sample. What about 82? It's again a fixed temperature, right? 82 is fixed temperature. It's not a range. So again, it's pure substance. And again, this is a range, so it's an impure substance. So we've got 2 pure and 2 impure substances. Now let's check out our answers. Substance B and D are impure. This is because they show a broad melting point range. Substance A and C show sharp melting points, so they are pure. Sharp means fixed, constant melting point. So yeah, B and D are impure and A and C are pure, and we've also marked that. B and D are impure and A and C are pure. Clear? Correct? Hope this makes sense. Okay, effect of impurities on boiling point and effect of pressure on boiling point. We'll be talking about this. Well, we've already covered what impurities do to the boiling point, but we haven't discussed this pressure. So we'll be talking about this and the key ideas in the next lecture. So stick around, guys. till the next lecture.